In this video, I will demonstrate a general chemical reaction between a sulfur-containing compound with a strong base sodium potassium hydroxide, as denoted in the question that I copied there above. So sodium hydroxide, which is NaOH in aqueous solution, means that there are both sodium positive cations with a +1 charge because they're in group 1, so they want to lose an electron to have a stable octet and be stable. And hydroxide ions with a -1 charge that are floating around in solution. So if you add the commonly known substance H2SO4, which is also called sulfuric acid, which is one of the leading agents used in the chemical industry because it's so corrosive and it's good for chemical reactions. So it's good for like labs, batteries, and manufacturing plants. So if you add a strong acid, like sulfuric acid, plus a strong base, like sodium hydroxide, you get a salt plus a water through a neutralization reaction because the acidic and basic properties are neutralized. So the pH of the resulting solution should be around 7, but it's not always the case. That's just for most neutralization base reactions. Of course, if you add a strong acid with a weak base, then you might end up with a pH that's slightly less than 7 because it might be slightly acidic. If you add a strong base with a weak acid, you might end up with a pH above 7 because you might end up with a slightly basic solution, given that you started with a strong base. So this reaction takes place via a double displacement mechanism. The H's in the acid, or the H in the acid, trade places with the cation in the base, the sodium in this case. So the H will combine with the OH, which forms H2O, so that's our water. This leaves the ion, which will trade places with the hydrogens and combine with the sulfate in the sulfuric acid, which is the negatively charged or anionic group. So it'll go like this, Na2SO4, because SO4 naturally has a -2 charge, and Na naturally has a +1 charge. So that's the salt that's formed, and that's why the pH gets neutralized. Because water is usually around a pH of 7, and it can be both acidic or basic, depending on environmental conditions and what other chemicals it is paired with.